Okay, we want to talk about the derivatives and the tangent line. So suppose we have a curve, okay, an arbitrary curve, smooth curve, and we know at each point there is a tangent line. For example, at this point, you have a tangent line, and at this point, you have a tangent line. At different points, you have a different tangent lines, right? So to find a tangent line, there is a very important information we should know, which is because the tangent line is a straight line. So we need to know the slope of the tangent line. If you know the slope of the tangent line and you know the point it touches at the curve, then you can use the slope point form or point slope form to find equation of the tangent line. So the very important information for the tangent line is the slope, right? So what is the derivative? The derivative, roughly speaking, is just the slope of the tangent line. Okay, so how to calculate the derivative? So we know that if we have a straight line, okay, and there is 2 points on the curve, on the line, this point and this point, and this is the x1, y1, and this is the x2, y2. If you have 2 points on the line, then we can use the old-fashioned formula for the slope, right? Slope. What is the slope? The slope is the rise over the run, right? The rise is y2 minus y1 over x2 minus x1. So be careful. You should pay attention to the order. Here's 2. Here must be 2 in the. Here's 2, here's 2, here's 1, and here's 1. You should keep the order, okay? On the top is 1 minus 2 minus 1, then the bottom should be 2 minus 1 also for the subscription. So this is the old-fashioned formula. For the old-fashioned formula to find the line, the slope of the line, we need 2 points. However, we only have 1 point, right, for each tangent line. So how to find the slope for the tangent line? Let's look at the following. So we have a curve. This is an arbitrary curve. Y equals f of x. We have a point here under the curve. We want to know then there is a tangent line. There is a tangent line. So the tangent line touches the curve at this point. We want to know the slope of this tangent line. So if this point is x, denoted by x values for this point, and here is the y values, since this is the y equals f of x, so the y values should be f of x. Okay, so this point is x, comma, f of x. So now we want to find the slope for this tangent line. However, we only have 1 point, right? We cannot use this old-fashioned formula to calculate the slope, because the reason is we only have 1 point. So how to do that? We use the following way. We assume there is a point, another point under the curve here. This point has the coordinate, x coordinate, x plus h. So the y coordinate would be f of x plus h. So this point is x plus h over, comma, f of x plus h. Then we have, since we can connect these 2 points, I didn't draw very well, but we assume this line connects these 2 points. And this line is called the secant line. So the secant line, the slope for the secant line is the slope of the secant line is equal to, we have 2 points, so the y coordinates minus y coordinate. So this would be f x plus h minus f of x over x plus h minus x. So this would be f of x plus h minus f of x over h. Okay, so we can use the old-fashioned formula to find the slope of this secant line. But it's not the slope for the tangent line. However, the next question is how can we use the slope of the secant line to get the slope for this tangent line? So the idea is the following. So this point x coordinate is x, and the x coordinate for this point is x plus h. So the distance between these 2 points is h, right? So now let's move this point, the red point, to here along the curve. Okay, move down along the curve, move to here. Then you have a new secant line, right? You continue this way. You continue move this point. For example, we move to here. Then you have this secant line. You can see that if we continue move the points along the curve in this direction, right, along the curve, at last, the secant line, when this point is very close to this point, or coincides with this point, the tangent point, then the secant line will coincide the tangent line. In other words, the secant line, when this point, the second point, move to the original point, so these 2 points coincide, then the secant line becomes the tangent line. So this is a limit process, right? When we move the red point along the curve to the purple, then to the blue, then continue, we actually, the distance between these 2 x values, which is h, when we move down, this h move to here, move to here, right? We continue to move to here, then this h will approach 0, right? So this gives you the following idea that the slope of the tangent line at the point x, f of x at this point, right, at this point, which is equal to the slope of the secant line, which is fx plus h, we just can calculate, right, minus f of x divided by h. This is the slope of the secant line. Then we take the limit. H approaches 0. When h approaches 0, that means this h becomes smaller and smaller. This h becomes smaller and smaller, right? So the points will become closer and closer to the tangent point. So at last, when h is very close to 0, then this point is almost coincide the tangent point, x f of x. Okay, so this is the idea to find we use the limit process to find the slope of the tangent line. So now let's look at the derivative, the definition of the derivative. The derivative of a function f of x, function f at the point x is denoted by f prime of x. What is f prime of x, which is the derivative of f at the point x, which is the limit h approaches 0 of fx plus h minus f of x over h. Okay? So this is the definition for the derivative. It's actually the tangent line and the slope of the tangent line at the point x, right? So now let's look at some remarks for this definition. So you see that if we input the different values of x, then this limit will give you the different value, right? For the different x, you have the different values. So this f prime of x is a function of x. Is a function of x. Okay. 2. What's this? This is actually from, we know, which is from the slope of the 2 points, right? That line, we know 2 points on the line. So we can use the old-fashioned formula, right, to get the slope, which is f of x plus h minus f of x over h. And this is called the difference quotient. Why we call it difference quotient? Because the numerator is the difference of the y coordinates. The denominator is the difference of the corresponding x coordinates, right? So the next question is, if this limit exists, we know that sometimes the limit does not exist, right? But if this limit exists, then we say f is differentiable at x. Number 4, which is about the notations. You will see in future many textbooks, they will use the different notation to represent the derivative. Okay, so here's some definition notations you will often see in our textbook. F prime of x, which is the derivative of f at x, we also write as d over dx of f of x. So this one is called a differential operator. This is called a differential operator, okay? Or you can write d f of x over dx. Or sometimes you will see, you just see d sub x of f of x. So this means that the derivative of this function at x. And there is another important notation which is called the Lebanese notation. Lebanese notation, which is, maybe I made I didn't spell it correctly. But anyways, this is called the Lebanese notation. Lebanese notation is df over dx. Okay. Why we write as a Lebanese notation, sometime you will see later. It's very convenient for us for the further calculation. Okay, so this is called the Lebanese notation. Number 5, we have an alternate definition. Which is, this is the curve we have, right? And then we have a point here. And then we have the tangent line. And if this point has the x-coordinate c, okay, so this point is c, f of c, and we have another point on the curve, which is x, the x-coordinate is x. So now let's connect these 2 points. So the slope of this, so this point is x, f of x. So the slope for this secant line is, the slope for the secant line is f of x minus f of c over x minus c. So now we let x approaches c. Okay, we let x approaches c. So this will give you the limit. Then we take the limit for this secant line. You see, when x approaches c, then this point will be closer and closer to the tangent point. At last, if these 2 points coincide, then the red line becomes the tangent line, right? So the slope of the red line becomes the slope of the tangent line. But this is the result for the limit when x approaches c. F of x minus f of c over x minus c. So here, this would be the derivative, right? This is the limit for this, the slope of this secant line when x is very, very close to c, then the limit will give you the slope for this tangent line, which is the derivative at x at c, right? This here is c, not x. So you can see the difference between these 2 definitions. One here is x approaches c. So this curve, this point will move down, right? They are moved toward this tangent point. And here is h approaches 0, right? H approaches 0. When h approaches 0, in other words, x plus h will approach x, right? So h approaches 0, so this point will move toward to the tangent point. So they actually the same thing, but use the different ideas. Here is we let the distance between these 2 points go to 0. And here we let x approach c. Okay? So this is the limit for x approaches c, and this is the limit for h approaches 0. So actually they describe the same thing. Okay?